Python's and/or operators have a hidden superpower. They stop evaluating as soon as they know the answer. This is called short-circuit evaluation, and it's not just elegant, it's measurably faster. Today, we're diving into the bytecode to see exactly how Python skips unnecessary work. We'll run performance tests to prove when this optimization saves you real execution time. Let's start with the basics. When Python evaluates A and B, it checks A first. If A is false, Python already knows the whole expression is false. B doesn't matter, so Python never evaluates B. Same with A or B. If A is true, the answer is true regardless of B. This isn't just logic, it's an optimization. Python literally stops executing code mid-expression. Watch what happens when we chain multiple conditions together. Here's where bytecode reveals the magic. For an AND expression, Python uses jump if false or pop. This instruction says, evaluate the first condition, and if it's false, jump past everything else. The remaining conditions never execute. For OR, it's pop jump if true. If the first condition is true, jump to the end. These aren't just instructions, they're skips. Python literally jumps over code in the bytecode. No evaluation, no function calls, no processing. Zero overhead for skipped conditions. Time for the benchmark. We'll test expressions with expensive operations on the right side. First, AND with a false first condition. Python should skip the expensive check entirely. Next, AND where everything evaluates. The difference is dramatic. The short-circuit version completes in 0.05 seconds. The full evaluation? 0.25 seconds. That's 5 times faster. The same pattern holds for OR. When Python short-circuits, it's not just saving operations, it's avoiding them completely. This matters in production code. Imagine checking user permissions before running an expensive database query. Put the cheap check first. If user.isAdmin is false, Python never touches the database. Same with null checks. Verify the object exists before accessing its properties. Short-circuit evaluation prevents errors and saves computation. The key is ordering. Put cheap, likely to fail conditions first. This pattern shows up everywhere. Input validation, conditional logging, guard clauses, even API rate limiting. Here's your optimization checklist. First, order matters critically. Put the fastest checks first, most likely to determine the outcome. Second, use short circuits for null safety. Check if X is not none before calling X.method. Third, avoid side effects in chained conditions. Python might not evaluate them at all. Fourth, for expensive operations, this can save massive amounts of computation. And finally, remember this works with any falsy value. None, zero, empty strings, empty lists. Python's truthiness system makes short-circuiting even more powerful. Short-circuit evaluation. It's not just clean code, it's optimized code. Python skips work at the bytecode level, making your logic both faster and safer. Order your conditions strategically, and let Python do the optimization for you. If you want to see more, like and subscribe.